Yeah, we are live now.
Okay, great. So, hello everyone. Welcome back to the BTCfi Summer Hackathon Workshop Series. My name is James from DoraHacks, and as the largest multi-chain developer incentive platform, it is our honor to support and host the BTCfi Summer Hackathon. The hackathon is live now. It ends in just under a month, and so we're really looking forward to seeing all of the amazing projects that are being built on Core DAO, on Core Chain as part of the hackathon. Today is the third episode in the workshop series, and we're going to be learning about building full stack dApps on Core Chain. So before I hand over to the team at Core, can I just make an announcement for any live listeners? Please feel free to ask questions in the chat, and we'll make a note of them, and we'll ask them at the end on your behalf to the Core team in the Q&A. So today for this third episode, I have with me Rumeel and Denali, who are both contributors at Core. So guys, if you're ready, you can introduce yourself and then let's kick off with the workshop.
Hi everyone, my name is Rumeel. I'm working as a contributor at CoreDAO. So today I will be with my colleague Denali. So Denali, you can introduce yourself. We will proceed it then.
Yeah, of course. Hi all, I'm Denali. I'm a blockchain engineer and one of the main contributors at Core. I sit on our blockchain engineering team, so help with like protocol features, but also touch a lot of different parts of the DAO. So help with things like onboarding new developers to build decentralized applications and things like that.
Perfect. Let me share my screen. Let me know once you guys see my screen.
Yeah, it
Is it visible, right?
I can see it.
Perfect. So today we are going for the workshop number 3, which is the building the full stack dApps on Core. The agenda of this workshop is that we will go with some of the builders program, that how we are incentivizing our builders, our developer community. We have different programs that we will cover. And after that, the Denali will go to the complete hands-on guideline with step-by-step guideline to go through how you will create applications on decentralized applications on Core. So before going to the next step, that I just give you the heads up about the Core. The Core is the most Bitcoin aligned chain, which is the EVM compatible dApps. This is the chain which is for the users. We have right now 18 million core chain addresses, 255 million total core transactions. Building with Bitcoin that we are utilizing, as in my previous workshops, we have mentioned about the core consensus protocol, which is Satoshi Plus, which is the combination of the decentralized proof of stake, decentralized proof of hash, and also decentralized proof of work and non-custodial BTC staking. So, which is the very novel and the unique consensus protocol. Core is based on it. So, in which that Bitcoin hash, Bitcoin miners, they are delegating their hash, which is almost the 50%. We have the BTC value, which is non-custodial BTC staking. They are staking their BTC, which is almost the value that now we have 200 million plus stake with Core. And we have a very good massive audience like you developers or the Kortoshis. We are 2.3 million, and the 260K Discord members right now we have. About the core developer programs that we are empowering, engaging, and elevating our developers. So we have multiple programs. This is not all about that you can just apply for the BTCfi Summer Hackathon. By applying with BTCfi Summer Hackathon, you will be eligible and you will get more or most benefits from our programs. For example, about the Core Academy, which is the learn of the basics of the blockchain, cryptocurrency, and about the core part basics of the core advanced technologies, how actually core is working, how you can build applications on core, what are the products that you have. It will be completely familiar with the Core Academy. We have the ambassador program. Ambassador programs, you can say they are the advocates building core dev communities. There are the 3 parts of the ambassador program, which is about the one community ambassador. Second one is about the technical ambassador, and the third one is about the student ambassadors. Community ambassadors are the one though who are building the retail community. Tech ambassadors are the one who are the technical background. They have a blockchain engineering experience, and the student ambassadors are those who are elevating the and providing the sessions, workshops into the university. So they are bridging the gap between core chain and about the students engagements one. Core starter program where you will get the industry leaders for the building Bitcoin secure dApps on core, where we have our ecosystem providers. You will get benefited from our ecosystem provider, for example, about the help on, you can get some discount of the products. You can go with other applications that what we deployed on our chain. You will get mentorship from them. We have our chain core ventures, which is the fundamental opportunity for you to grow your project on core. For example, you are applying for BTCfi summer hackathon and you are get selected, you are get rewarded, you win the prize. But it's not limited that you will be into the prize feed side. You will go to the next step, which will be our core ventures part. We will see about your applications. We will give you the complete mentorship guideline to go on to the next step, which is our core ventures will play the role. Core wish list, that you are already participated into the hackathon. So we have a wish list, core wish list, where you can see that what actually the demanding application and the innovative ideas that we are looking to build on core foundations grant. This is the similar one that you applied for the grants for your applications for your projects. Core ignition builder incentive program, this is for especially for the builders. For example, you have win the project. So in next 3 months, what is your TVL, what is your daily active users, how much number of transactions that you have did. So based on this one, you will be get rewarded on a monthly basis. So the reward of the core ignition builder incentive program is almost 400K core tokens. So it's a very good reward, and we are rewarding our builders on a monthly basis. So Denali, it's your part that we are building the full stack app on core today. And yes, please go ahead.
Yeah, happy to take over here for the coding section. So I'll share my screen here and then we can get into it. Just a moment while I set that up. Perfect. Great. Can you see my screen? I'm going to assume yes. So here is our dApp tutorial code repository on GitHub. So this is a public GitHub repo that you can come to, and it's hosted at core.org and then /dApp-tutorial. And this link will be provided to you guys through the workshop and other places. So in this tutorial, we're going to walk through creating a little bit of a spoiler alert, an application that looks something like this. You're going to write a smart contract and you're going to deploy it to core testnet. And then you're going to interact with that smart contract by sending it a transaction with a number and reading that number from the smart contract. And all of this then is going to have a user interface, which is what you're looking at here, or a application. And you can see here, there's some input to write and read that number. And we'll go through this whole process together. And so the goal here is to get you familiarized with, one, connecting to core testnet, two, writing and reading some basic Solidity smart contract code, and then three, how do you actually put this all together into a full stack dApp that allows you to deploy that contract to chain, interact with that contract, and then display the data that's in that contract to your users in an application that looks something like this. So I will walk through here. I think I actually need to change which screen I'm presenting so that way you guys can see my code editor. So just a moment there. Apologies for the slight delay. Let's see. Perfect. This should work wonderfully. Can you see my screen here? I think it is showing down at the bottom as my presenter screen. There it is. Wonderful. Great. Now I can kind of switch back and forth between my code editor and the application we'll be building. So what I've done here is I've taken this repository and we'll walk through some of these steps here. So the first thing to do is to create a dApp tutorial folder on your computer. And the way to do that is to come into your favorite IDE or code editor, anything that allows you to have access to this terminal right here that you can type commands into. So I've already executed these first commands, and here this command makes the directory, and this command just transfers my my terminal to it. And then you'll want to run through this series of steps that basically installs Hardhat, which is what we'll be using to program our smart contract. So you can see I'm just entering it down here. So here it's like installing Hardhat. We'll let this run. Perfect, just completed. So we'll go to the next command here, which is setting up some additional Hardhat stuff and Chai, which is a helpful framework for our development. And now we can initialize our Hardhat project with this npx hardhat command. Perfect, we are good to go. So let's walk through the code structure of our project a little bit before we just start editing things. So at the kind of introduction, right, we were talking about how we'll be programming a Solidity smart contract. So here in our dApp tutorial root of the repository, we have a folder called contracts. Right now, there's a contract in here called lock. We'll make some changes to this, but this is where our Solidity smart contracts are going to go. Then looking a little further down, we have a folder called scripts. This is where we will write scripts that Hardhat will then run to deploy contracts, interact with contracts, things like that. So the contracts directory and the scripts directory are very critical for actually deploying our contract to chain and that kind of piece of everything. Here in the SRC here is kind of the, let's say, top level code directory for our actual application. So in here, we'll have our app, which we'll get into. We also have, some of the logos and things that you see over here, right? And various kind of application-based stuff. So let's walk through actually setting up the project and what it all looks like. So the first thing you want to do is install and configure MetaMask Chrome extension, and you want to set it up to use the core testnet. So we have a detailed guide here that you can click into on exactly how to do that. I've already got my MetaMask here already connected. This is my core testnet developer address. I'm connected to the core blockchain testnet. How to get all that set up, we have a great guide for that. So make sure to check that out if you don't already have your MetaMask configured to core testnet. Then what you want to do is create a secret.json file in your root folder, and you store the private key of your MetaMask wallet. So how that works, I'm not actually going to show you guys my private key, so don't get too excited. But what you do is you go in here and you click on account details, and then you come in here and you click show private key. It will ask you if you're super sure, and make sure not to show this to anyone else, because if anyone sees your private key, they have access to your whole wallet. But what you want to do is you copy your private key from here, and you come over to our dApp tutorial code repository, and you'll want to make a new file called secrets.json. So you can see here, I've already created the secrets.json, and I've put my private key in there. And you'll want to do that in order for your application that you're building here to be able to use the same blockchain address that your MetaMask is connected to. You'll also see I have a pretty large balance of this test core here. in order to get T-core or test core, which you'll need to deploy the contract to core testnet, we have a faucet. And you can just search core chain testnet faucet. Here on the dApp tutorial that we build, we actually have links to the faucet. So just for example, to show you what it looks like, looks something like this, and you would just paste your MetaMask address in here and press confirm you're not a robot, and then get your T-core, and then you'll have your test core that allows you to interact on core testnet. So let's just pop back over here to some of this setup stuff. This is set up for your hard hat config, and what this does is it basically to take a step back. So remember how we had to connect our MetaMask to core testnet? Okay, we also need to connect our code base to core testnet. And the way to do that is this hardhat.config file. So you can just copy this as is, and you can come over here to the hardhat config and just paste it in. I've already done that, so you'll notice that this is the exact same line by line text that you'll find here. And something to note here is you can see that we are taking that the contents of the secret.json file that we just created with our private key, and we're loading it as the private key. And then we are passing that private key to the testnet account. And now we have hooked together our MetaMask that's in our Chrome or our Internet Explorer window here with our project. So you can see how we're starting to put the infrastructure pieces together that are going to allow us then to seamlessly develop. So now that we've set everything up, we can get to some of the meaty stuff, which is writing our smart contract. So here we'll navigate to the contracts folder of the root directory of the project, which we already took a look at earlier. And we see there's this existing file called lock.sol. And here we're going to actually delete the lock file, and we will replace it with this storage.sol file. So to do that, we'll just copy the storage.sol. I'm actually just going to create storage.sol. I'm going to paste this in. I'll save it. And it's asking me here to delete the lock file. It's actually important. And if we don't delete it, we might run into an issue later. The main reason why, just for those who are interested, is this lock file has a different version of Solidity than this storage file. And so if we try to compile both at the same time, basically our compiler isn't set up to handle both right now. It's possible to make it that way, but for simplicity, we're just gonna get rid of the lock file and we'll just work on the storage file. Perfect. So we can actually take a look at what this contract is doing. First of all, we mentioned about the version of Solidity. So this is saying that the Solidity compiler from version 7 to 9, that could be version 7.5, version 8.2, version 9.0, all are actually just one less than 9.0. But all of those versions will work to compile this contract. If we try to compile it with a Solidity compiler that's like version 2, it won't work. So make sure to just be aware of the version of code that you're writing. Here we can see that there's a comment from the developer of this that explains the contract, which is to store and retrieve a value in a variable. And we saw a little snippet of that earlier when we were taking a look at the dApp user interface here, right? You have write number, read number. So those are actually connected to this contract. So the main thing we do is we declare that it's a contract and we name it storage, which matches up with our file title. So that's great. And there is one global variable in here. It is a uint256, which is an integer basically, and it's called number. And this is the one piece of information that our storage contract is going to have. And it's got two functions. The first one is function store, and it takes a uint256, so it takes in an integer. And it's a public function, meaning that anyone in the world can see it, call it, interact with it. And it has just one line of code. It basically sets our input integer to this global number. You can see, right? So the num basically gets set to number, boom. So if we were to pass 10 to this, and the number was 0, and we pass 10 in the store function, then number is going to be updated to 10. There's a second function, which is function retrieve. You can see here it's also public, so accessible to anyone. And then view means that it doesn't modify the contract's state. And to help explain what that means, we can think about how the contract state is number. It's basically the things that are owned by the contract. It's only got one, right? This number. So this store function, it actually updates the contract state. So you can think of it as like a writing function. It's writing something new here. But here, retrieve, it's not writing anything new. It's just reading the state. It's just checking it out. So that's why we add this additional prefix here, it's view. So it's just a view function. It doesn't modify state. And why that's actually important is that this function store, in order to call it, you have to pay gas and send a transaction to the blockchain, because updating a contract state costs gas. Every time you write new information to a contract or have the contract do some like computation for you using its state, all of that costs gas. And that's why we have to send a transaction and pay for that service, right? Here, to retrieve or just view that data, it's actually free. It doesn't cost any gas. And so these two functions actually result in very different things. And we'll see that when we go through the rest of this tutorial, that this function doing this costs gas and requires us to send a transaction, whereas this function does not cost gas and does not require a transaction. So important to understand the difference here between these two. But in summary, we have our storage contract, our global variable. We have a function to update that number variable, and then a function to read that number variable. Great. Now I think we have a good understanding of our first Solidity smart contract that we've put together. So sliding back over to the, there's also a kind of explanation of it here in the tutorial. So, if you want to refresh as you go through this tutorial yourself, there's lots of good stuff in here to check out. Then let's actually get into deploying this contract. So the first thing we need to do is compile it. Remember, we were talking about how it only compiles a certain version of Solidity. So let's try to just compile this. So npx hardhat compile is the command. Let's run it. Okay, it says nothing to compile. Actually, the reason it says that is because I already compiled this same contract before I started sharing. So hardhat's actually looking at my like artifacts and build info and saying that there's nothing to compile because I've already compiled it. At least that should be why. Correct. So I deleted my old contract, and then I ran the my old compiled contract, and I ran the command again. And you'll see here, now it's telling me that I compiled one Solidity file successfully. And it's just telling me about the environment that it was compiled for. So great. Now we have our compiled smart contract. So now we can deploy the contract and interact with it. So let's create this scripts. Or specifically, we'll create one script. And what the script is going to do is it's going to deploy the contract, and then it's going to call, and it's conveniently named deploy and call.js. It's going to call the contract, and it's going to store a number in it. So first we'll copy this, and you'll need to create a scripts directory here, and make sure, it says this in the tutorial, but make sure to create the scripts folder in the root of your project. It's easy to, accidentally maybe put it under one of these other directories, but it won't work. works. So make your directory here in the root, and then you can come and create this file deploy and call and paste into it. We'll go through exactly what's happening here. So firstly, we're going to fetch this storage contract. We need to know what we're deploying. We're deploying the storage contract. Okay, so we're going to load it. And then here we're going to deploy it. And we should see a message that says the storage contract was deployed to, and then it will tell us the address that the contract was deployed to. It's then going to call retrieve. It's just going to check to see what the number is on the contract. Remember, we have this global number. I think we can anticipate that it's going to be 0 because our storage contract here, it doesn't specify a number. So I believe it should just be 0. Then it will, right here, it's going to call the function store on the storage contract, and it's going to pass as the argument to that function the number 100. So remember here, this is the store function it's going to call. It's going to pass it the number 100. That'll come in here and it'll get set to this number. We'll wait for that transaction to confirm, because on the blockchain, you have to wait for transactions to process, get confirmed, everything like that. And then we will check to see what that number is by using our retrieve function. So here, right, function retrieve, we're just going to return it. Great. Okay. I think we can run this and see if it works. So we've copied this in. Here, there's a few notes about making sure that your MetaMask wallet has the T core tokens for the core testnet, which we talked about earlier. And now we can run this command from the root directory of our project to deploy the smart contract to core chain. So I'm just going to copy this command here, npx hardhat run scripts / deploy and call.js, paste that, and run it. You can see here I'm using a different version of my node here. It shouldn't cause any problems, but it's giving me a little warning about it. Great. Okay. Look, our script has returned some output. Our storage contract was deployed to this contract address. We called retrieve, and as expected, the value of the number is 0. Now we called store, and we set the value to 100, like we expected to. And now we're going to call retrieve, and the value was updated to 100. So you can see how each step of this script has been run and is printed out. Now let's go check out this contract that we just deployed, like see what's happening with it, and see if we can see what these transactions kind of look like on chain. So what I'll do here is I'll copy this smart contract address, and you can actually come into the core scan testnet explorer. Something to remember is we have a core scan. We have like a production blockchain explorer called core scan. And coming in here, if you were to search this contract, I don't think anything would show up because this is for core mainnet. Now, we just deployed the core testnet. So make sure you're using the core testnet explorer, not the mainnet explorer. Otherwise, you're going to be looking at the wrong thing. So you can see I was already using this to check out another address. So let's just paste in our address that we deployed. We can see it's the same one, right? Like it ends in 360E. And here we're ending in 360E. Great. Okay. And we'll search it. Cool. Looks like there's a contract here on core testnet. And 2 things have happened. There's been 2 transactions. The first one, it says it's a contract creation transaction. And then the second one here is actually our transaction that wrote the number 100 to the smart contract. So this was the storage.store call right here. This created that second transaction. The first transaction was created by our storage.deploy. Great. So we can see that it exists. We can check the status of different transactions on chain to some extent. Now, great. So you can see here, we got our expected output. And there's a note here, which is important, is to make sure to save the address of this storage contract. Just this one right here, the same as this one, right? Because we need to plug this into our full stack application, our dApp, so that it points to our contract and not some other random contract on chain. So let's actually now walk through plugging this smart contract that we just deployed into our front end. So first, we can come in and see here. Sweet. There is this source directory, and this, as we mentioned at the start, is where our application is actually going to be. By application, I'm referring to the code that creates this. And we can take a look at what that looks like. So in here, we're going to have, in our primary component, we have an app.tsx. And here at the very top on line 10, it's actually asking, like, what is the contract address that we are going to use? And so you can see here, there's a contract address already in here. Let's see if it's ours. It looks like it's not, right? This one ends in 684, and ours, as noted, was 360E. So let's actually grab our deployed contract address and plug it in here to replace that one, the old one. Just want to make sure we're talking to the right contract, of course, right? You can see here, we also are setting up some constants, like we are setting up the testnet core scan URL. This is going to be important later on. Basically, how this all works is it's a application that's built with React. If you're not familiar with React, definitely check it out, and I would recommend picking up some React skill sets. It's a very popular and very useful framework for developing like full stack applications. You can use it for like web-based applications, which is what we've built here. You can also use things that are quite similar to it, like React Native for applications on your phone. That'll run there quite well. Very popular, and definitely recommend. So we're not going to do a full React tutorial right now because it's I think a little bit more time than we have available today. But to give a little bit of an overview, we're going to set up some state, kind of the same way our contract had state. This application has state. So the state is going to be our current account, which is the same thing we have over here in our MetaMask, right? This guy right here. We have our current account. We're going to have the stored number, and we're going to have the retrieve number. And why that's relevant is if you look here, if I were to read this number, it will pull from the backend, it'll show me it, and then this number will get saved in the state of the application itself. So it doesn't always have to talk to the contract to get the number 3. I get it once, and then it knows that it's there. The reason why this is 3 instead of 100, by the way, is because this is actually a app that is hooked up to a different contract. You can note here, this 684. So that was actually the old contract, right? So that's why that's a 3, and just so you don't get confused as to the difference there. The first thing we do here is we make sure that we have MetaMask installed. Then we go and we make sure that there is an account that is logged in to the MetaMask. Then here we define a sequence of actions that we're going to do if the user calls the store function. And so what's going to happen is if someone calls the store function in our React app, we're going to grab this like Ethereum object from the window, and that's actually basically like the injected provider from MetaMask. So we're going to use MetaMask in order to interact with the Ethereum blockchain. Is basically what this is saying right here. Then the signer is going to be our MetaMask address. And then the storage contract is, here we can see it's using the contract address, the ABI. So up here, right, it's using this contract address. The ABI is basically like the interface of the smart contract. We can actually just take a quick look at what an ABI looks like so you can see what's happening here. So I'm just going to click in here. We have this storage.json file here, and it has an ABI, and really quickly, it's basically this interface, right? So you can see there's this function named retrieve. It tells you that it has outputs. It returns an integer. It's a view function. You can see it as a function. And then there's a second function named store. You can see it's not, the state mutability is like different because it's not a view function. It updates state, and it doesn't have any outputs, but it has an input. The input's a number. So what this ABI does is it tells us what exists on the smart contract. Our app doesn't actually need the Solidity code in order to talk to the Solidity code. It just needs the ABI, because the ABI explains all of the Solidity code that exists on the contract. So that's why here in the app, all we need is the contract address and the ABI. And that's why here, when we set it up, we just need those two things. The signer is basically the MetaMask account, just the way that Ethers creates the contract. It includes it. It basically means this is the contract address, this is what's on the contract, and this is the guy who's going to be signing transactions and talking to the contract. So anyways, in our store function, we can write to the contract. We will call now our storage contract.store, the store number, wait for the transaction to be confirmed. And then we have a similar kind of setup for retrieve. Some other stuff's in here. We have some utilities like the connect wallet button. Then for these things like storage, we're going to define buttons, and we're going to map the action of the buttons to like sets. The action of the button on click is store, and store, as noted, is this thing. So when we click the button to store the number, it's going to go and grab the MetaMask from our window. It's going to set up a object of the storage contract so we can talk to it. Then we're going to store the number on the storage contract, and then we'll log any errors if we get them, and hopefully we don't. So that's kind of how this works. There's a button that has some functionality, and that functionality hooks through MetaMask to your deployed smart contract. So let's check out how this kind of works in practice. Let's see here. I think there should be some, and a lot of this is also explained here in like the key implementations about like the adding smart contract details. So like here, for example, it's telling you to update the contract address on line 9 of the app.tsx, which is right around here, right? We already did that. But the idea here with the instructions in the README of this GitHub repository is even if you don't attend this workshop, you can still walk through all the steps and get to a functional working application by following each and every one of these. Great. So let's test it all. So let's run the command npm run dev from the root of the project to start the application. Ooh, I think I just deleted something from here. I did. Okay, got to be careful there. I'll undo that. The command is npm run dev. I'm just going to copy paste it. Don't want to delete anything else. Great. So what this does is it starts our application, and it starts it at this location. So we can take this like URL and paste it into our Google Chrome or whatever we're using. You can see like this is basically that URL. If we do this, boom. Now there's our connect wallet button. Boom. Great. We have connected, and let's try to read this number. I think it should be 100, right? Because our contract address here, if we click on this this is the same contract that we deployed earlier. Makes sense because this is the contract that we plugged in on line 10 to the application. Great, let's try to write a new number from our application. So let's do 35. So I'm gonna write the number 35. Now, when I click this, it's going to force me to send a transaction because I'm updating the state, which costs gas, and therefore I need to send a transaction. It'll automatically pop up your MetaMask and execute that transaction for you. So we can wait a little while that transaction confirms. And we can actually check and see if it's confirmed yet by pressing this read number. Oh, sweet, already confirmed. Core is pretty fast, which is a huge plus for development and for your users of your application. So here we can see now we can read the number 35, and pressing this read number button doesn't require a new transaction, right? That is basically a run through of the main functionality of this full stack demo, because we have, I'm just checking, yeah, we are at the congratulations final thing. So we can walk really quickly through what we did, right? We set up our code repository here. We wrote a contract and went through what it means. And then we deployed that contract. And through this script, we actually were able to store a number on that contract. We then grabbed that deployed address and plugged it into our front end. And then we started the front end, which is visible here. And we interacted with that contract through the front end, both writing and reading that number. So quick run through of what your final state should look like if you follow all the steps here in the dApp tutorial. Yeah, I think that's everything in the initial phase. Happy to take some questions and figure out exactly what kind of things you guys might want to know in addition to this initial kind of spiel.
Thank you, Denali, for the complete go through of the applications, the demonstration of the dApp. The question is that how we can verify the smart contract on Core testnet.
Yes, so to verify the contract on Core testnet, you can use several different strategies. There's 3 ways you can do it. The way that we recommend is to actually use Hardhat, which is the same framework that we were just using to develop. The reason that we recommend that is because you can verify your contract in the same code repository as you develop it in, which is more automatic and programmatic, and it's less likely to have errors. But there's other ways you can verify as well. If you actually go to CoreScan or testnet CoreScan, there's a button that says verify contract, and you can from your smart contract, you can paste in the code, paste in the ABI, paste in the compiler version, and you can verify it through the CoreScan verify interface. You don't have to do it through your terminal via Hardhat. So those are the 2 different ways I recommend. There's a third one, which is using a kind of a different approach other than Hardhat. It's programmatic as well, but I would recommend doing either the Hardhat or the CoreScan approach. And we actually have a guide for all of this. It's on our docs. It's called contract verification, and it gives the exact steps of how to verify contracts, either via Hardhat or via
API verification, and the one is about the CoreScan one. So there is just I want to share with our developers that if you are running an issue to verifying a large 1,000 plus lines of the single file contract for the verification, then we will recommend you to switching your code into the standard JSON format for the verification. So you will never get the error one. So into the API part one, there are the libraries that we are not supporting right now onto the testnet one. So you have to be, these are the limitations that we have right now. But if you have a 1,000 plus lines of code that you are going to in your single file, the best approach is to switch to a standard JSON format for the verification one. So let me share my screen. There is one slide which is pending. 1 second.
Those are good clarifications, Rumeel, about contract verification. And I'd be remiss not to mention, because someone might run into it. Right now, Core does not support the latest version of Solidity, which is like version 20. We support up to like 19.9, but we will be supporting that version pretty soon. But if you run into any issues there, we can contact us, and there's a workaround that we can direct you through. And otherwise, just maybe wait a month, and you won't have any issue with verifying that version of Solidity as well.
Perfect. So thank you, Denali, for the more clarification. So guys, you can we have shared the link of the dApp tutorial into our comment section. You can just fork it and install it for the future contributions and the future updates part. Don't miss the prize pool for the 250K prize pool allocations into our BTCfi Summer Hackathon. Do apply, build cool projects, and apply for our programs about the grants program, Core Ventures, Ignition Builder program 1, starter kit program as well. So you can get all the benefits with different programs that we are offering to our builders. Yeah. Is there any questions or anything, so we can go through it?
Okay, thanks guys. Thanks Denali and Rumeel for that very detailed run through in the workshop. I don't think we've got any comments through at the moment. I wanted to just ask myself quickly, Rumeel, maybe it'd be useful to share a bit more details about the core ventures for the winners of hackathons. Is there anything in particular that they're looking for in the projects that are submitted in the summer hackathon?
Yeah, so the most major thing is about that your application must be onto the testnet part 1. So based on the testnet one that we will see about, we will do the evaluations of the projects. Okay. And if you are into the pricing winning site one, then we will, our BT experience market team and our DevRel tech team will help you to scale up your project. We will give the one-on-one mentorship as well. And top of it, that if your application is replied to the mainnet part, then there is a particular time for the Ignition Builder program. So you have to eligible for the Ignition Builder one, that you have to maintain some of the TVL, DAU, and the number of transactions that will from your dApp site. And based on this, I think it will be a 1 to 2 months. You will get some of the you will be into the eligibility criteria, and the next step is that you will go about to the core ventures part. Then where we have our team, their venture team, they are evaluating the projects and doing the partners and doing the grants from our core grants program, core foundation grants. So these are the benefits that you will get, and it's not limited here. That our DevRel team, our engineering team, that if you are facing any technical issues while building your applications, in terms of the tech side that Denali mentioned about 0.8.19.1, about the testnet contact verification. But if you have any issue on the bridging side, you have some pre-compiled addresses that you are required. So Denali, he is very good experience into the bridge part as well, and is right now managing our engineering stuff into the bridging stuff. So it's not limited to about the technical side one, that you will get the support with our marketing team as well. Our BD's team will support you to streamline all the process and the application launch onto the successful launch onto the mainnet part.
Great. Okay. Yeah. Thanks for that. So there's one question I've seen from Marco Perez. He says, is there a way to do pen testing from a mobile if he doesn't have a laptop or PC?
What was the question? Sorry.
Isn't there a way to do pen testing from a mobile if you don't have a laptop or PC?
I think a lot of the pen testing tools that you would use on your laptop are probably accessible from your phone. It's going to be a lot harder to interact with them without, I think, like maybe some more like specifics about like, what kind of pen testing or exactly what's like the goal here. It might be a little hard. But I think most of it, you should be able to use your mobile in order to to run through the steps of different things.
Cool.
But the recommendation approach is always use your laptop or PC for the pen testing.
Yeah, for sure. Okay. Well, thanks, guys. If there's nothing left to add from your side, thank everyone for watching and for tuning in to the third workshop in this series. And just a reminder, the BTCfi Summer Hackathon is still ongoing. There are 25 days left. So there's a link in the chat if you want to get access to that. Encourage everyone to get involved. And we're really excited to see what the builders are building.
Perfect.
Thanks, Denali and Rumeel, for your time. See you next time.
Thank you, everyone.
Of course.
For
Thanks, guys.
Thanks, guys. Bye-bye. Bye-bye.